Hello everyone, I am Namita from CSCB. Now we are going to see about interprocess communication. So the contents involved in it are interprocess communication, needs of interprocess communication, types of interprocess communication and uses, problems involved in interprocess communication, types of communication in IPC. So let's see one by one. So first, interprocess communication. So what is interprocess communication? It is nothing, it's a mechanism that allows the process to communicate and synchronize their actions. So the process can be independent without affecting each other or cooperating. So there are two types of process, independent and cooperating. In independent system, operation concurrently on a system are those that can neither affect the process or be affected by other process. So in this, operation is executing concurrently which is not affected by any other process, or it does not affect any other process. So it's not harmful for any other process. It also does not affected easily by any other process. So cooperating process is next one. So it can affect or affected by other process. That is, it can be easily affected or it's vulnerable to the process surrounded it. Next. So it's IPC, mechanism that allows the process to communicate and synchronize their actions, which we already see. So before communicating, both the systems or process will handshake and confirm their communication. So after handshake only their communication will start and they share the information or resources, etc. So if the handshake is not accepted, it cannot share any information to the another process. So it's most important concept in IPC. So next, why we are using IPC? For information sharing, like multiple process may need access to the same data. So in case of we are storing the data in a file, the multiple process is requiring the same data, we have to allocate it individually and equally to all the resources requiring it. And next, computational speed up. So the task can be divided and processed in parallel manner. So a single task is broken into subtasks. So it makes the process to be more easy and simple. So that it's broken into the subtask and it is performing the different distributed process for each task. So it makes the process to run faster so that we are using the computational speed up. Next, for resource sharing, it allows the sharing of hardware, memory, etc. So resources are nothing but the hardware resources, memory resources and accessing of file, etc. which all comes under the resource sharing. So next, modularity. So modularity is breaking the complex task into smaller manageable process. So we are having the organized complex task which is broken into subtasks and they have the different process or threads running in each subtask. So after breaking we are having many subtasks, each subtask perform different process. Next, convenience. So convenience is nothing but it enables the multitasking at the same time. So individual user can run several programs at the same time to perform some task. So for making the task to be very easy and simple, we are making the task to break into subtask. So that makes the individual user to complete the task at time and also it increases the simplicity in the concept. Next, types or ways of IPC. So here we have mainly two types, shared memory system and message passing system. So below system represents the process involved in that. So like that first we have the process A, process B. So first diagram represents the message passing system. So process A is moved to the message queue and process B is moved to the also message queue. So the both are processed in the message queue and then kernel is present at the lower level as it's the core component of OS. In shared memory, if you see the second diagram, process A and process B is commonly moved to the particular shared memory and kernel is at the bottom. So next, shared memory. Shared memory means the multiple process share the same memory space. So we are making the process to be broken into subtasks. So we have multiple processes at that time after breaking. So it all share the common memory space. So it performs faster but not necessarily easiest. So this process is very faster but it cannot be easier because we have to synchronization the data. So the communication between one data to another data can be made easy through the shared memory. So if we are having two process A and process B, in between we are having the shared memory to act as a common communication path between two processes. So next we are having shared memory. So for shared memory we are having the diagrammatic representations like multiple processes are moving to the common memory space, like read and write operations are also performed in that particular place. So the problems in this concept is producer consumer problem. So there are two main processes involved in this, producer and consumer. So producer producing some item and consumer consumes that item. The two processes share a common space or memory location is known as buffer. So buffer is the temporary memory storage space where temporary data are put into that for later accessing. So like producer is producing and consumer consumes, it seems like sender and receiver. So sender sends some data to the particular memory place and receiver when requires the data it takes from that place. So like that in same concept is used in the producer consumer problem. So producer produce the item which is stored in the buffer and from where the consumer consumes the item if they are needed. So like that the buffer is the memory space where the data are stored by producer. So consumer when needed that data they are accessing that storage to access the data. Next, unbounded buffer problem. In unbounded, we have two versions. So first one is unbounded buffer problem and bounded. So in unbounded, producer producing more number of items and there is no limit on buffer size. So large number of data we can be continuously producing and we can store into the buffer without any memory limit or something. But in case of bounded buffer problem, producer can produce up to certain amount of item. So after that it starts waiting for consumer to consume it. So after producing certain amount of data, it waits for some times to make the consumer to consume all the data. In case of sender and receiver, sender sends some data and wait for acknowledgement from the receiver. So if the receiver is okay, then the data is fetched by the receiver and then again sender starts to send the data. So like that, this is known as bounded buffer problem. So the main difference between unbounded and bounded is in unbounded we don't have any buffer limit or storage limit. We can produce multiple number of items and can get stored into that. But as in case of bounded buffer problem, we have the limit to certain amount of item and we have to produce only less number of items until it will have to wait for the consumer to consume it. So next bounded buffer problem is given as brief. First, the producer and consumer will share the common memory, then producer will start producing the items. So before starting the production, the producer and consumer will share the common memory. From that, the producer start producing the item. If total produced item is equal to the buffer size, producer will wait to get it consumed by the consumer. In case of bounded, if produced item is equal to buffer size, we should not have to exceed the limit, we have to be in limit. So in that case, if the producer producing the item equal to buffer size, then the process stops immediately to make the consumer to consume the items. Similarly, the consumer first check for the availability of item. If no item is available, consumer will wait for producer to produce it. So as well as the producer is waiting for consumer to consume, the consumer also wait for the producer to produce the item. So when consumer is checking for a particular item, if it is not available, it does not move back, it waits for some time and makes the time for producing the items to the producer. So it makes the mutual connection between both producer and consumer. So if there are items available, consumer will consume it. If the required items is available, consumer will not wait for any time. It will consume the items required by it. But if it is not available, in that case, it waits for the consumer producer to produce it. So next, comparison of shared memory and message passing method. So in shared memory, process A and B move to the common memory space, and in case of message passing method, process A and B are combinedly moved to the message queue present near the kernel. So this is the key difference between the shared memory and message passing method. So message passing system is, in a message passing system, there are no shared variables. IPC facility provide two operations for fixed or variable sized message. So sending and receiving. In case of message passing, we have no shared memory. So process communicate by sending and receiving message only. So if process P and Q wish to communicate, they have the two types of communication like direct and indirect communication. So they establish a communicate link or exchange the messages through send and receive. So communication will take place in two ways, like establishing a link or exchanging the message through sending and receiving. So for example, we are given the process involved in that message passing method. So first, processor is sending the memory data stored in the memory to the common space. From that common storage space, it's moved to the processor's 2. That is like producer to consumer, it is moving through the buffer. Next, key issues involved in that. So there are many issues like in message passing system that can be explored in the next subsections like direct or indirect communication, synchronous or asynchronous communication. So direct communication means, with direct communication the sender must know the name of receiver to which it wishes to send a message. So sender select the receiver to which it needs to send the message, and there is a one-to-one link between every sender and receiver so they can communicate directly. In symmetric communication, the receiver must know the specific name of sender from which it receives the message. So it's similar to the direct communication. But in case of asymmetric communication, there is no necessary communication to be handled between the receiver and sender. So the one-to-one link establishes the direct communication. Next, indirect communication. It uses the shared mailboxes or ports. So in direct communication, the user communicate directly, but in case of indirect, they are using mailbox, port, etc. So only one box can read any given message in a mailbox. So single process can only read the contents in the mailbox. So initially the process that creates the mailbox is the owner, and one allowed to read is a privilege may be transformed. So OS must provide the system call to create and delete the mailbox. So OS is the main component acting to deleting and creating the boxes or mails through system calls. So synchronous and asynchronous communication. So synchronous means messaging involves the clients that wait for the server to respond to a message. So messages can be flowed in both directions, from or to. It can send or it can receive, both. Next, asynchronous. It involves the client does not wait for a message from the server. So clients do not wait for the message from the server. It is used to trigger a message from the server. It does not wait until the server provides a message. It triggers automatically to use the message. So next, even if the client is down, message will complete successfully. So it does not depend upon the client's active. So it is down also, the message will complete successfully. So it is a one-way communication. The flow is only one way. It can send or otherwise receive. It cannot perform both the operations. So it's known as one-way communication. Thank you.